Had a little time today. Pulled the service manual of the CA-800 Fisher. And I was just curious about making some modifications. I was thinking about the power. Let's see. Power cord. What else did I say? Binding posts. Binding posts and the op amp. And I was also thinking about the potentiometer as well. That would be a bear to find a replacement for that one. I'm not sure I'm going to be able to do that. So I might just blow it out, clean it right there. Because I want to keep the original look of this thing, and I'll explain when I get in there why. So let's look at a couple things, peek around. Here's a nice block diagram of it. I'm not going to use the phono stage of it. I've got my own phono preamp that I prefer. But if I'm going to be inputting devices, I won't be using record out because I don't use cassette decks. It has a mic input? Really? Yeah, it does. Microphone. No, it's got a headphone output, but it's got a microphone input. How many amps have that? Wow. So I'd be using something like the auxiliary input or the tuner input. What does PB stand for? I know it's got to do with, that's the tape monitor, right? Yeah, so when you go to record out and then you come back in through the tape monitor, so that's not something I'd be interested in. So I'm interested in the auxiliary and the tuner inputs. Let's see what we got. I can't really see. Phono, auxiliary, tuner, and tape monitor. Okay. All right. So these guys come in. They're selected by that function switch you see right there. We're not going to have the tape monitor down here. It's going to stay right there. And we're not going to be using this is mic switch. Jack in, mic on. So I guess the switch is built into the jack. So when you shove the mic in there, it automatically switches this over. So signal comes in, comes through here. There's mic right there, mixing amp. So when you're not using the mic, the mixing amp will mix your whatever audio you're playing along with the microphone, so you can be kind of a DJ. Is there a mixing knob here so you can control the mix? I don't know. Anyway, that doesn't matter. So the signal is going to go this way. We're bypassing the mic amp. Okay, then we go through the balance, the volume, the loudness control is kind of integrated right in, it's part of the volume control. I'll show you that in a minute. Then we got our biggies here. We got our preamp and our power amp. And then this unit apparently is fused. We'll look for that in a minute. And we're going to have, looks like maybe a relay that goes to speakers. Not sure, I haven't looked at that. And then for the meters, the way this works is the meters tap off the final output signal right here. it's just showing a reduction via a resistor. I'm sure there's more circuitry than that to give you a headphone output. And then the meters, that signal goes into a meter amp to isolate, so that the meters don't affect the output voltage. So it goes into a meter amp that's kind of a buffer or provides enough voltage to drive the meters themselves right there. And then there's another kind of meter on the Fisher, and that's the LED meter, that little thing that blinks. So it's got another amp for that. So that's the whole circuit in a block diagram. Come back to this in a minute. So I mentioned I want to change the power cable, and that's right there. Looks like it's a 2-prong, not a 3. Now, when the power comes out of your house, let me draw this. You got a little plug, and one of the two is fatter than the other one. It's this skinny one that's actually hot. And this other one is grounded. All right, so I got to figure out which is which. I don't know if this is a polarized plug or not. I haven't looked at it, but it's a 2-prong, and might not be because we have black and black here. And one of these, let's call this the hot side, and let's call this the grounded side. So the hot side will go into the power switch right here, and it's switched, and then it'll go into black of the power transformer. And then the grounded side looks like it bounces over to something that looks like it gets strapped to the chassis. I have to look at that once I get inside through a resistive element. And then it's also tapped here to go into the yellow. Okay, so there's our inputs right there. Black and yellow is our mains 60 cycle input to the power transformer. So when you hit that power switch, you're effectively hitting a switch right there to bring the hot side of your power right to the transformer. And if I'm going to bring in a 3-prong, I'm going to have to figure out how to do that. I just might put a fatter 2-prong in. Oh, I know how to do it. Okay. So that's one of the things I said I wanted to do. The other thing are the speaker binding posts right here. And so there are a left and a right, and there's speakers A and speakers B. So it looks like we have yellow and black, red and white. Same thing here, yellow and black, red and white. So one of these is going to be for speakers B, the other will be for speakers A. And these two, like yellow and black, will be positive and negative for, like, for example, left, and positive and negative for right. And I'll have to figure that out once I get in there. And I only want one pair of binding posts. So I only want left and right. All right, so that's another thing I want to do. Now let's get into the actual schematic, and I'll walk you through this a little bit. Don't worry if you're intimidated. I need to get a refill. I'll be right back. You know, I always mean to cut these parts out. In what little editing I do, I forgot to cut one of these out the other day. Sorry about that. If I forget to cut this one out, then you're just going to have to deal with the pause. Okay. So here's our auxiliary input. Let's say I plug my DAC into that. And here's our, we come down to our switching here, the things that will, these are the switches that select our sources. So let's say these, it looks like right now we've selected phono right here for the signal path, but let's say phono is not selected and we push the switch and we flip this over to here, so the auxiliary is selected. So here's our signal for auxiliary will come into here, and then it will traverse down to there, right there, and then this switch right here will get flipped down to there as well for the other, that's both left and right channels. And then the way these schematics work is we're only going to follow one channel from here on out. Looks like we're going to follow the left channel. All right, so then we go through tape monitor, and if that's selected, it'll send out the auxiliary signal through the tape monitor. For those of you who remember how tape monitors worked when we had cassette decks. But we don't care about that. So this switch and this schematic goes off to the left here, but basically this signal will go this way, come out, and back up to here. All right. All right. So our signal keeps traversing this way, and it comes up to our volume potentiometer right here. And that's our volume pot. And when this little arrow right here, when you rotate it, when this little arrow is all the way down here, we're at the ground state. So there will be no signal at all. That's when our dial, our volume knob is rotated all the way counterclockwise. And with this little arrow is all the way up here, we're getting full signal that would be clockwise, and somewhere in between would be like a reasonable volume level right there. You can see that all these little things here, and I'm not going to get into it, this is integrated with our loudness circuit, our loudness switch. And I won't even get into that because I leave that off. And that's why I say the entire pot, this 200K audio tapered pot, has all these extra connections on it for this loudness switch. So if I replaced that pot with like an Alps or something off the shelf, it wouldn't have these things, and I'd have to eradicate the loudness switch. There'd also be fitment problems with the shaft and all this other stuff, and I don't think I want to get into that right now. So I'm going to just clean the pot and hope that it's not quite as scratchy. Okay, then our signal comes over through a 1K, and here is, it goes through a capacitor, which at AC is going to be a short circuit. This is just a DC blocking cap. And we come into our op amp. This is IC01, and this is an operation, it's a dual operational amplifier. There are two channels, left and right. So this is our left channel, and that's our right channel right there. And op amps only have, two inputs. Well, they have, let me just show you, I'll tell you what. And this is the op amp I'd like to replace. Okay, it's a NJM 4558. Let's look at that right now. And all this circuitry around here looks scary, but this is just feedback. This is negative feedback to the op amp. So our signal goes into pin 3 of the op amp. Okay. There we are. Okay. It's a dual high gain op amp, and I guess it has some attributes. I mean, all op amps have high input resistance, so it's just funny, but it's got some attributes, I guess, that make it good. In here, it's going to be a DIP, or a dual inline package, inside our machine. And here's the pinout diagram. So let me drop back. Pin 3 is where the signal goes to. Okay, so the signal goes to the non-inverting input right there. The output comes from pin 1. Okay, so the output comes from here. And then here's some feedback that goes back to pin 2. And pin 2 is the inverting input. So this is just a very typical op amp. No big deal. Like I said, the other side is for the other channel right there. And then pin 8 and pin 4, this is our power supply. One's for negative, one's for positive. Right there. All right. So we're going to go through our op amp. Now, let me just also mention this. If I'm going to replace this op amp, which I think would be a great idea, it's going to require desoldering that thing. Got to be very careful. What I thought about was this right here. What? Oh, I forgot the name of that. Forgot the name of that company. Forgive me, I forgot the name of the company. I didn't. It's eluding my mind. But what you're looking at right here, it's a great name for a company too. I just having a gaseous brain moment right now. Most op amps look like this right here. That's the dual inline package, and they are integrated circuits. You know, the circuitry itself is on a substrate in here. You know, it's microscopic. This is a high quality audio grade discrete op amp made out of discrete surface mount components. And it would be this is a really cool concept, and it would be it's a little costly, but this will be a direct drop-in replacement for that op amp. And I'm thinking about doing that. So that's another thing. That's why I wanted to bring that to your attention. Okay? So again, our output is from pin 1. We go through another capacitor, which is a short circuit at AC. And we head in this direction. Now, I want to say this. These are the tone control. This is the high and low pass filters for the tone controls. And the way these tone controls work, and I don't want to get into detail. I haven't even quite figured this out yet because I don't care much about it. But this is our treble potentiometer and our bass potentiometer. These are the knobs on the front for bass and treble. And these affect filter circuits that will ultimately feed back additional information to our non-inverting input that will affect the tone. I keep them flat, and I could actually clip this and just bypass this stuff altogether, but I don't want to. I don't care. I just keep it flat. Don't care about the signal path or any modifications to it. So let's just carry on with our signal. Then we come this way, and we're exiting our preamp right here. And here's our amplifier. So here's where we just were right there. We're heading into our amplifier. Here's our balance control between our left and our right channels. Let's see. Get that right. Yeah. Actually, I'm just looking at this. This is not quite what I thought. I'm just looking at this. Let me go back up. I'm just thinking out loud. I might have to cut this out here. What is the output? The output's number 7 on the second op amp. That's right here. Yes. Our second op amp has an output. Yes. Oh, I'm so freaking good. So these are the left and the right channels right here. I'm just looking down here at what this thing is and what it does. And I think that's the mixing amp for the mic. I don't care about that op amp, so I'll leave it alone. Oh, I'm so good. So here's our left and our right channels. And you can see we have a potentiometer right in between that will do the mixing to give us our balance control. And when this pot is right in the middle, we have equal balance. Okay, great. Let's just stick with our left channel like we're doing. So let's keep going this way. And you see our right channel goes this way and heads way down here to a similar schematic for its channel. Okay, but we only care about the left channel because the two are the same. So let's head into our amplifier section right now. And here's the amp. And there's nothing I really want to change in here, but it's just of interest. And I'm going to tell you one thing about this amp that I think it's just my theory that makes such a big difference, why it sounds so good. I said accident of design before. And you can see mostly we have discrete components. And this might look like an IC, and it kind of is, but it's kind of not also. I want to talk about that in a minute. And I think this thing right here is amazing. Everything is bipolar junction. There are no MOSFETs in here. Okay, so let's keep going. We've left our preamp. And, oh, let me back up. I said once before I was thinking about maybe just bypassing the op amp altogether, like just hopping way over to here, bypassing the tone controls and bypassing the op amp. And upon studying this, I can't do that because this op amp provides gain. Okay, irrespective, if that's a word, irrespective of its tone control section, this op amp provides gain, voltage gain, that we need in the preamp section to drive the amp section. So I just can't bypass this. I need that op amp in there. All right. Now, and I actually ran these feedback numbers for a this would be a non-inverting op amp configuration. And I ran these feedback numbers the other day, and it looked like it's providing a decent amount of voltage gain, so it's got to be there. Okay, back to the amp. So, our signal proceeds along its happy way, and what we have here, let me just circle it. Is a difference amplifier, or commonly referred to as a differential amplifier. It's one of the most common input stages that you'll ever see in a classic Class A/B amplifier. Won't get into how it operates. I've actually designed these things. One of my college projects was completely related to the design of a differential. This is a current source right here, but was the design of a differential amplifier. And they have magnificent characteristics, and especially with respect to common mode noise rejection. So they reject noise rather well, and they provide a small amount of voltage gain. And they have nice input resistance and output resistance or impedance characteristics, and they're just a great way to start the journey of a signal into a power amplifier. And conveniently, and this is what's convenient, this is a difference amplifier. Okay, so number one, these things reject, I'm not going to write this out. They reject common mode noise. And what that means is any noise, and common mode means it's noise that's present on both the positive signal carrying wire and the negative signal carrying wire, noise that might have been introduced internally, for example. And it will reject them because it only amplifies the difference between this side and that side. And anything in common is not a difference, it will get wiped out. That's number one. Number two, it provides voltage gain. But number three, it provides two convenient inputs. So our signal gets input to this side. And we have another nice side we can provide another input to. And that other input is for negative feedback. Right there. Negative feedback, which we know that negative feedback reduces total harmonic distortion, provides a wider bandwidth, reduces output impedance, and has other characteristics that are necessary in transistor design. So that's why this differential amplifier, which is biased in part by a current source down here, don't need to get into any more than that, is a wonderful way to get things started. So we go into here, we get some voltage gain, a little bit of noise reduction. We come through this bipolar junction NPN transistor, and we come into, and I don't want to get into detail about this circuitry here, it's not that complicated, but we get a little bit, it appears to me we get a little bit of voltage gain, but this is more or less a buffering circuit that will be able to sync the current required for this device. That's the way I see it right now, without getting into ultra deep analysis. It's snowing like crazy outside right now. Pretty cool. All right, so we come into this device right here. So we get a little bit more voltage gain right there. We got some voltage gain there. So I would call this stage right here, combined with these two, more or less like a driver. This would be an input. These would be drivers. And then we come into this guy here. And I think this is an amazing device. And what this device is, can you find it? Oh, here it is. It's a Sanyo device. And these are called Darlington pairs. These are bipolar junction transistors. And this is complementary Darlington pairs. Now, sometimes you could actually discretely populate your circuit board with this kind of a circuit and build it yourself. But this is all built into one integrated circuit. And I don't really call this like an op amp. This is an op amp. This is like a heavy-duty integrated circuit. But this is just really helping you out, reducing your parts count by building these Darlington pairs. And the Darlington pair takes the beta, which is the current gain of a transistor, and it multiplies the beta of that one times the beta of that one, so you get a much higher current gain. And it's complementary. You can see this is NPN transistors, and these are PNP transistors. They're complementary because each of these handles a different section of the waveform right here. And we don't need a phase splitter like we do in vacuum tubes. So this section might handle the top half of the waveform, and this section might, okay? So this section might source the current for the top half of the voltage waveform, and this section might sink the current for the bottom half of the waveform. And collectively, we have an A-B circuit. It's probably biased a little bit into class by virtue of some of these, the diode and this Darlington pair here, biased a little bit into class AB, right there. So that's what this device is. Here's the data sheet from Sanyo. Darlington type pure complementary circuit. And I just have a gut feeling that the wonderful characteristics that I hear in this amplifier are probably as a result of this. Because this stuff here is standard. And we go back to the preamp, standard, and I'm not a big fan of op amps. I mean, but collectively speaking, by accident of design, putting all this stuff together on one circuit, it just, again, I'll use the word emergent properties. It emerges as something just fantastic. And these things are inexpensive, and it keeps the parts count down on a circuit board. And yeah, I'm keeping this. I think this is the heart and soul, honestly, of what makes this thing tick. And so our signal goes into it, and this is a current amplifier. So we've already amplified all the voltage we need to out here, and this thing is going to amplify current to send it into our loudspeaker. So our signal will, it's like our top half signal, our sourced, and then here's our bottom half signal here, our sunk current. So together we get a nice big signal there. We go through this network here, which is like a Zobel. Basically, this is a kind of a semi-standard thing you find in series with an output of a transistorized amp, and it's for lack of a more detailed description, it's for stability. And you can look at it this way. This is a very small inductor, which at audio frequencies, they kind of show this signal going through the resistor, but it's not. At audio frequencies, this signal is bypassed by this inductor, which is almost zero resistance. All right? So then we go through the fuse, which I don't happen to appreciate fuses. I might, but they have that there because I don't see any protection circuitry up here. You can build in protection circuitry for short circuits. I don't see any real protection circuitry. That's why they have the fuse. All right, and then we traverse down, and eventually, if you follow the schematic, we'll get into the. This goes right to the speaker binding posts, and that's one channel. All right, so yeah, I think the op amps in order, the new power cables in order, and where did I start? Binding posts. That should be op amp and power cord, and clean the pot. And I think that would serve to improve this wonderful piece of history. And let me know, should I do it? I mean, it's going to be a lot of work, but I did it with my Yamaha A1000. I didn't replace any op amps, but I did with the A1000, I did the power cord and the binding post, and I love it. And whether it's psychological or not, I thought it made a difference. But yeah, thinking about doing it. All right, Stereopolice. Thanks for joining me. Maybe next time we'll open the top of this thing and get a look at what's going on in there and see how challenging this work might be. All right, it's the Fisher CA-800. Let's decapitate it. Let's see what we have. Really? Seriously? Hmm. I'm going to take this off and show you around in a minute. Gotta find my glasses. All right, in order to figure some things out, I need this bottom panel off. There are a lot of screws here. So if I'm going to do this now, I'm not going to rebuild this until I'm done with the updates, the mods. Some of these I don't know if they're all necessary. I'm just going to start taking them off and seeing what gives. Can't look in there and tell. It's amazing you have 4 screws to keep the top cover on, but you know, like 20 of them on the bottom. And the reason I need to access the bottom is because I found everything I need for my mods, but I can't find the op amp. I can't find the op amp. I think I know where it is, but it's going to be on an inverted. Now, there's a screw with some crap in it. Had some gunk in it. There we go. The feet should not have to come off, as best I can tell. Look at all these things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. An odd number. I'm missing a washer. I gotta check something. Nope. One washer missing. All right. Oh yes. How am I going to figure that out? I see. Okay. Wow, this is an upside down. Well, not relatively speaking, but this is our preamp circuit board right here, and this is our amplifier circuit board right there. Well, let's start with the power cord. Look at the tone controls. A few things on top, then we'll flip it on the bottom, see what we can figure out. All right, running low on battery. I was tethered, but running low on battery here. All right, start with the power cord. It is 2 prongs. It is polarized. See the focus? Focus. Hang on. See, it's got a skinny one and a fat one. Okay, that helps me. All right. Power cord comes in right there, and if you remember, I said one of these wires that come in, got one of them marked. One of them has a white stripe, one's not. But remember, one of them had a strap with a resistor in it, and that's right there, and it does get strapped to the chassis. So that's got to be grounded. So that's helpful. And looks like I can replace that with a nice fat one. I've got good access for soldering. So the power cord shouldn't be a problem. Speaker binding posts right here. Looks like I can unscrew this whole assembly. There might be there's a big square area that'll be cut out. And here are all my wires. right here that go to A, B, left, positive and negative, left, right for A and B speakers. I'd have to clip those, strip them, get them soldered in, but I think I can work with that. Okay, so the binding posts on the back side are right there. Well, these aren't posts actually, these are binding inserts, but I'm putting legitimate posts. Look at that little wiggly right there. Look at that wiggly. He's coming out of there. What is that thing? Some interconnection to something else for Fisher, I guess. I might. Look at that wiggly. I might have to terminate that. That's a nice transformer. Everything works good. Now let's go to our power board right here. You can see these are massive. Okay, these are the complementary Darlington pair devices, and they get attached to the heat sink. There's those coils, those inductors on the output. This is our power supply area here. That's our rectifier, and these are filter caps. Be a good idea to change those. Maybe I need to add a filter cap change. Nichicom. Okay. Here are the output fuses. Be a good idea to change those too, since they're old. Be a good idea to change every electrolytic in here, but I'm not ready for that project yet. I want to see how this sounds. So what did I say? Filter caps. Good idea to change them. These are 6,800 microfarad electrolytics, and why am I not seeing a voltage? Can you see a voltage? I'll have to study that. 69 WV. Okay, is that 69 volts? It's not watt volts. All right, but they're polarized. There's the negative sides right there. I mean, and with transformers, you see VA, and volt amp is a watt, but transformers don't dissipate power, so we don't typically rate transformers in watts. We rate them in VAs, their capabilities, before they get saturated with their magnetic flux. But honestly, 69 WV. Tell me what if you guys know what that means. Is that 69 volts? Maybe I'm having a brain fart. I would have to guess. I'll check the schematic. I don't think this power supply goes that high. But anyway, I'm just saying this so I know what to buy when I go back to watch this video. Might have to take some physical measurements on there too, because they got to fit on the... And I'm going to have to remove that circuit board. Oh, that would be no, maybe not. I could access it from the bottom. I don't. All right. So here's the input board over here. These are where all the inputs come in. Auxiliary and tuner are down here. The phono preamps come in here. So this IC right here, that's an op amp, and this circuitry up here with the capacitors, and there's a ceramic capacitor and some electrolytics and some resistors in that IC. This is the phono preamplifier up here. So that's not the IC, that's not the op amp that I want. Then our circuitry comes over here. Here's the volume knob. You can see that's a little loosey-goosey. I might have to tighten that up. Here's the pot. There's the open access where we can spray it out. A couple resistors on this board. There should be a couple of caps on there if that's, well, no, just the resistors, okay. And then here's our input selector board right here. These are switches. You see them work. All right. And then our preamplifier board is this big board down here that runs all along here. It's kind of what I'd call upside down. And that's where we're going to find, here's our, by the way, here's our power switch right here. And we do have some protection and a fuse. A couple more fuses there. And here's the lamps. These are the big lamps for our beautiful VU meters. Here's the individual lamps for the selection indicators. So let's turn this thing upside down and try to find the op amp that I want to replace. And there's a shield here that's soldered on there. If that op amp is under that shield, I'm going to have to remove that. That might be, things can become a pain in the roof. All right. All right, so what I was saying is the shield will have to be removed. It is soldered, it's grounded right here, this green wire, but the rest of it is floating. So I could desolder that, or I could just cut this thing, remove it, do my work, bring it back, and put it in place and resolder the cut portion. Because it's not attached, it's got a little tab up in there where it stays in place, but I think I can deal with that. So it looks like everything's accessible. Let me give you one more look around with the flashlight. There are those big ICs right there. Or not, you know, I'm reluctant to call them ICs. They're not really integrated, well, they are, but they're not. The complementary Darlington pairs. All right. So note to self. New fuses, at least those two new fuses, the ones that are in the signal path. New filter capacitors in the power supply as well. Tighten up the volume pot, clean it, and deal with the loosey-goosey thing back here, whatever this is. Maybe it doesn't look good, but I'll deal with that in some way. So those are the mods I want to do. I'm going to have to get my workbench back in operational order. It's a mess in there. Okay, let's think about it. What should I put the work into it? I mean, I've already got it torn down. I really don't want to rebuild it right now until I get the parts and get this job done. Or should I do all of these things or just some of these things? I don't know. I'm just thinking out loud. Stereopolice. Let me know what you think. Hope you enjoyed this. Fisher CA-800. It's minimalist, but it is brilliant. Ciao.